Hello, everyone. Today we're going to be going through the 6.04 quiz, which covers the topics of interpreting and comparing linear relationships. So first, let's talk about interpreting them because we need to know how to understand them, how to explain what's going on before we can compare. So for this scenario here, we're being told that this graph represents the cost of renting a bike based on the number of hours the bike is used. Interpret the y-intercept and the rate of change, the slope. So when we look at the graph, I can see it matches everything I just read, that our title here is bike rental rates. And then our x-axis, even though it's being used and labeled with the variable t, that's still our x-axis, that's the horizontal one. That's representing our time, and it's in hours. And our graph is counting by ones, so every dash is 1 hour. And then our C, otherwise known as our y-axis here, is the cost. And then notice that in this one, their graph is counting by fives, 5, 10, 15, 20. So that is something that we'll need to remember. So first, let's identify that y-intercept. Remember, the y-intercept is where your line intercepts, where it touches that y-axis. So that would be right here at 5. So our y-intercept is located at the point 0, 5. Now we're being asked to interpret it. Basically, we're being asked to say what it means. What does this 5 represent according to this story? The easiest way to do this is basically just to figure out what your labels are. Your labels typically tell you what it means. So our y-intercept is located at 0, 5, and our x-axis here is time. So in this case, that means 0 time has passed, 0 hours has passed. So it's time. And then the 5 is our y value, and our y values are all representing cost. So that's $5. So to put this together, we're being told that at the very start, so at the very beginning, we're going to have to pay $5. So we have a starting fee, or you could call it a flat fee, of $5. So no matter how long I rent this bike for, whether it's 30 minutes or whether it's 18 hours, I'm going to have to pay a starting fee of $5. Now we need to know what the rate of change or the slope is. Remember that when we're dealing with slope, there are lots of synonyms, there are lots of other words that mean slope. Slope, constant of proportionality, rate of change, unit rate, these are all meaning the same thing. Typically, we use rate of change or unit rate when it's a real world scenario. When we have an actual story attached to it, you're more likely to hear either of those vocab words instead. So if we want to identify that slope, remember that you need to pick 2 points on your graph. So we already have one here, which is our y-intercept, and we want to choose the next point. If possible, it's best for you to pick a point where it crosses your grid lines perfectly, because then you don't have to estimate. Sometimes that's not possible, but usually it is. So I'm going to choose this spot right here because our line intercepts. It crosses those grid lines perfectly, so I can have nice whole numbers. All right, remember our slope is our change in y over our change in x, otherwise known as rise over run. So we rise up 1 space. But remember, our graph is really counting by 5, so I really went up 5. And then we're running over 2 spaces. The x's are counting by ones, so that is a true 2. So 5 over 2 is our rate of change, our slope. But typically, you've been told by me to leave that as a fraction. However, the times like this example here that you don't are typically when you're dealing with a real world scenario, specifically money. Because if we're talking about money, yes, it's a fraction of something, but we don't really write money in fraction form. We write it in decimal form. So I want to go ahead and divide this out, simplify my fraction, and turn it into a decimal, making it 2.5. Now, for part 4, to identify what it means, It's honestly same concept as your y-intercept. Find your labels. If you label your numbers, you'll be able to figure out what they mean. So your 5 was you rising. It was your change in y, which was dollars. And then your 2 is your change in x, your run, and that's 2 hours. So we know that our rate is it's $5 for every 2 hours, but when we simplified that to the unit rate, it's 2.5. So in proper form here, that means it's going to cost $2.50 per hour of renting that bike. So to kind of piece this all together here, we're going to have to pay a flat fee of $5. And then every hour that we rent that bike for, it's going to cost us an additional $2.50. All right, let's try one more like this before we move on to comparing. So this graph here represents the height of a candle based on the number of hours it burns. Interpret the y-intercept and rate of change. So when I come over and look at my graph here, this matches what we've just seen. We have the title, and our y is the height of the candle in inches, and then our x is the time in hours. And notice that for the x-axis, even though it may initially look like it's counting by ones, notice they're skipping lines. So it's really counting by halves. So we'll have to remember that in a moment. All right, first up though, let's get the y-intercept part done. So our y-intercept is located right here at 0, 9. So now that we've located it, let's look at those labels to help us know what it means. So the 0 is our x value here, which is time. So that's 0 hours. And then the 9 is our y value here. It's that height of the candle in inches. So what does it mean? Let's put it together in a sentence. Well, it means when I purchased this candle before I even burned it at all, because of course, if you burn a candle, the wax decreases. So it makes sense that we have a decreasing line here. This candle is going to get shorter and shorter. It's going to shrink. We have, a height of 9 inches. So a couple ways you could say that is, the candle starts out at 9 inches tall. You could also say, before the candle is lit, it is 9 inches tall. There's several different ways you can word it as long as you're getting that same point across that at the very beginning, before anything started, this is its height. Let's identify that rate of change, that slope. So we already have our points labeled for us here, which is kind of nice. So let's go ahead and highlight this second point. Now let's find our slope, change in y over change in x. So I'm going down 2 spaces because I'm decreasing, because I'm going down. It would be a -2 over our change in x. Now remember, our x here is counting by halves. So even though we go over 2 spaces, we're really going over 1 whole, because this would be a half, this would be 1 1/2, etc. So if we simplify this, we have a slope of -2, which negative matches, it's decreasing. So what does it mean? Once again, get those labels. So that -2 is our change in y. So it's decreasing 2 inches, and then our x is time per hour. So that is our rate. So our rate is the candle decreases in height 2 inches every hour. And just like above, you could word it differently, but the main points to ensure you have is that it's decreasing. That's the word that tells us it's a negative slope. And then it's decreasing 2 inches every hour that it burns for. All right, now let's get into comparing, and we're going to go through several different ways that you can compare. This problem right here is similar to question number 1 on your quiz. So if you missed number 1, this is hopefully a great example for you so that way you can understand how to do it, learn from those mistakes, and then get it right next time. So this graph right here shows the distances traveled by 2 runners over several minutes. Which runner is moving at a faster rate? There's a couple of different ways that we can show our work here. And since this is the first one, I'll show you a variety of methods so you can see what works for you. The first way that you could figure this out is honestly just by looking at the graph. Because when we're talking about our slope, or more specifically, in this case, our rate of change, when something is increasing, when they're going faster, it's going to be steeper because it's going up very, very quickly. So it's going to make it a very steep slope, a very steep line. So by looking at this right here, I can see that A is steeper than B. So it kind of looks like to me, A is going a little faster. They're probably going to reach their destination or reach the end of the race faster than runner B. Now, the second thing we can do is to kind of prove this, to talk about, make sure that we're not reading it backwards or we're not, making things up by just looking at it. You can pick a point in time and identify where each person is. And that'll help you know who is faster. The trick is, if you're comparing, you need to make sure you're selecting the exact same point in time so you can have a true and an accurate comparison. Our graph here is not labeled. That's okay. We can assume that it counts by ones. And even if it's not, that doesn't really matter because it's not asking what is the rate. It's just asking who is faster. So if we just assume this counts by ones, let's just look at, say, the 3-minute mark here to see who is faster. So at the 3-minute mark, right here is runner A. And we're going to have to estimate, but like I said, that's okay. Estimating isn't a big deal, especially because we just really want to know who's faster. We don't need the exact number. So we can see at 3 minutes, runner A was approximately 5.5 kilometers away from the starting line. Where at that same point in time, at 3 minutes, right here is where runner B was. Runner B was only 3 kilometers in distance from that starting point. So right there, we can see, well, A is greater than B. Clearly, runner A is faster. All right, the last way I'll show you how to do this is you could calculate the slope. You could calculate the unit rate. Now, again, there may be a little estimating involved, but if we look at the numbers we have found here, because it's a proportional relationship and starts at 0, we can just divide this out to get our unit rate. So runner A went 5.5 kilometers in 3 minutes. When we divide that, we see that they ran, estimated here, about 1.83 kilometers per minute. There's our slope. There's our rate of change for runner A. Then runner B went about 3 kilometers in 3 minutes. 3 divided by 3 is 1. So their speed is about 1 kilometer per minute. So here's another way that we just proved. Clearly, runner A is faster than runner B. He is our winner. I should have circled that in blue since I did everything else with runner A in blue. Let me fix that in case any of you guys are taking notes, then the color coding all matches up. All right, let's look at number 2 here, comparing linear relationships. So same type of problem, just this time we have a decreasing graph instead. So Mike and Ellie, they race home from the park. The graph shows how far each person is from home after a given amount of time. All right, so this kind of makes sense. If we interpret, we see what we're doing here. So this is where they're at. This is the park. And then they're racing home. So it's decreasing because they're getting closer and closer to their house, to, their home. And then our X is the time in minutes. So this time, we're just going to do 2 different ways instead of 3 ways to get your answer. So first way is just by looking at the graph. Well, when we have a decreasing graph, if we're trying to figure out who's steeper, the steeper they are, the closer you are to having a vertical line, because that means it's super duper steep. So based on this, it looks like Mike is going to get home sooner. And even if you kind of look at the graph here at the, x-axis, it does in fact look like Mike gets home sooner. So Mike is probably the faster person. But let's pick a certain point in time to compare them to see if we are correct. So 1, 2, 3, let's pick 4 minutes this time. So right here is where Mike is at after 4 minutes. So it looks like we're really close to that 4-kilometer mark, maybe 4.1, super close. We'll just go ahead and say 4. So Mike, maybe 4.1 because it's not perfect. So Mike is about 4.1 kilometers from home after 4 minutes have passed. Well, Ellie is up here at 4 minutes, and that's kind of right between 5 and 6. So Ellie is about 5.6 kilometers away from home. All right, so once again, we just kind of proved Mike is a little faster than Ellie. All right, let's read our question here. Now that we know Mike is faster, our statement, though, says Ellie's rate is blank than Mike's. So if Mike is the faster one, that means Ellie's rate is less than Mike's. All right, this is similar to question 4 on your quiz. Now we're going to continue to compare, but we're going to compare 2 different formats. Instead of both of the pieces of information being on the same graph, we're going to compare a table and a graph. So this scenario here says if each business requires a 2-hour minimum stay and a pet owner wants to board a cat for 2 hours, which business should the pet owner choose? Well, this one's set up kind of nicely for us because if we're wanting to know what the answer is for 2 hours, we can just look at both the table and the graph to see where they're at 2 hours. Start with the table. So it's the first one here. We're pretty lucky. We can see that at 2 hours, it's going to end up costing us $7. So this Cozy Critters is going to be $7 per 2 hours. Now, we want to know where it is for our graph, for our absolutely perfect pets. Even though there's no labels here, our table had labels. And because we know it's the same thing, because we're comparing, our first one here is our X. So our X represents the hours. And then our second column is our Y. So our Y is representing the cost. So we can find 2 hours. So we're going to come over here to 2 hours, and then I'm just going to go up until I hit my graph, because that's going to tell me what the cost is for 2 hours. And that's located right here at halfway between 4 and 6 would be 5. So for absolutely perfect pets, it's $5 per 2 hours. All right, when we compare these two, if it's $5 for absolutely perfect pets, $7 for Cozy Critters, if we're just basing things off the money, this pet owner should choose absolutely perfect pets. That is our winner. Now, we're going to do this problem one other way, because let's say it wasn't so nice and easy. Let's say they were asking, how much it's going to cost for 3 hours. Well, when you look at your table here, it doesn't give you the data point for 3 hours. So another way that you could solve this would be finding your slope, finding your unit rate, and then using that to figure out how much it's going to cost you. So if we just clear all this temporarily to make a little bit more room, if we want to find our unit rate, we want to find our slope here when we have a table. Remember, you take your change in Y. So the difference between 7 and 14 is 7. and then we'll divide that between our change in x. The difference between 2 and 4 is 2. So that would be 7/2 is our slope. Since we're dealing with money here, we want decimal form. So 7 divided by 2 is 3.5. So that's telling us that for Cozy Critters here, it is $3.50 per hour. Perfect. Oops. Now for absolutely perfect pets, let's do the same thing here, only we're going to find our slope from the graph. So I'm going to look for 2 perfect points. I see the y-intercept down here is at -5, and then I see the point that we used earlier at 2, 5. So our graph is counting by ones, even though it's labeled every other line. So we have a change in y of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 10 spaces over 2. All right, which gives us $5 per hour. So then you have your unit rates. You can use that to compare, or you could use that to find other missing information. So that's another way you can do it if it isn't so clean cut and just kind of giving you the answer already in the table. All right, let's do one more problem together. This one is similar to number 5 on your quiz. We have another comparing one here. This time we're going to be comparing a word problem with a graph. We don't have a table and a graph. We just have the word form of our information. So Simon and Libby are reading the same book. The graph shows the number of words Simon reads over time. Libby reads 225 words per minute. Select all the statements that are true. All right, well, if I'm going to compare, I need to have the same information for both. And I see that Libby's slope, Libby's unit rate is 225 words per minute. So I need to find the unit rate. I need to find the slope now for Simon. So if we look at our graph here, thankfully, they've labeled our points for us, especially since these numbers are so large. So if it's the words that Simon reads per minute, let's calculate our slope from our 2 points. Now, with this, you could use the graph and count rise over run, but if it's a little harder because these numbers are so large, let's kind of go back to one of the other things we learned this unit, and that was just finding the slope from 2 points. And we can make a table out of it. So if you have 2 points here, we're going to use our first 2. We can put them in table format instead. So 3 and 540, 8 and 1,440, and then we can use that table to find our slope. Sometimes that's a little bit easier if we have really big graphs or graphs that are hard to read. So our change in y here is, we can use a calculator if you need to, so we can take the 1,440 and subtract from that the 540, and we can see it's changing by 900. And then from 3 to 8, that changes by 5. Change in y over change in x, rise over run. So we can take 900 and divide that by 5, and we get 180. So Simon here is able to read 180 words per minute, where Libby can do 225 words per minute. So let's use that knowledge to help us figure out which of these answer choices are correct. So Simon reads faster than Libby. Nope. Libby's 225, Simon's only 180. Not true. Simon reads 180 words per minute. Yeah, we figured that out. That's true. Libby reads 250 words every 2 minutes. Well, we don't have a graph for Libby, so we can't look at the graph to know. But if we know she takes 225 words per 1 minute, Well, let's take this. There's a couple different ways you could do it, but let's take this problem here and divide it out, find the unit rate, and see if we get that answer of 225. So if we take 450 and divide it by 2, we get 225, which is what we just had. So that one's true. After 1 hour of reading, Simon reads more words than Libby. That's not true because Simon reads slower. So if you wanted to, apply it, we have the minute mark here, but there are 60 minutes an hour. So if you took 180 times 60, did the same for Libby, Simon still isn't going to be faster after an hour because he has a slower rate per minute. So these are the only two choices that are correct. All right, well, I hope that this helps you understand a little bit better how to interpret and compare equations. A lot of it really is focused on looking at your labels, making sure that you are comparing the same thing, so finding that unit rate or finding that same point in time so you can have a good and an accurate comparison. If you need anything, please make sure you reach out. Bye.